In lab, you guys were taking a look at friction, and you noticed that friction is a force that opposes motion. And in fact, that is the definition of friction. It is a force, so you do have to keep that in mind. And remember, force can cause acceleration. And I say motion or intended motion because friction can act even if something is at rest. We tend to think of friction trying to slow things down and stop it, but it can also prevent things from beginning motion. Friction arises because there's interactions between the object and the surface it's sitting on, or if it's like air resistance, the fluid it's moving through. So there's several kinds of friction, and we divide them up based on how they're acting or when they're acting. The first one to look at is static friction. If an object is at rest, then static friction acts against applied forces to prevent the object from moving. So what I mean by that is, initially yesterday we had this mass sitting on the table or a block, and you guys took and pulled on it with your force sensor. Well, before you pulled on it, all we had was gravity pulling down and the table pushing up, and those two forces were balanced. But as soon as you started pulling this way, it didn't move because another force popped out this way, and that's the static frictional force. It tried to prevent that thing from actually starting its motion. But eventually you were able to apply enough force that this was able to overcome the static frictional force, and then this object started to slide across the table. However, as soon as you stop pulling, it's going to slow down and stop, because once it's in motion, then there's still that frictional force, and that frictional force is trying to balance or counteract the force that you're applying. If you actually wanted this thing to speed up instead of just remain at a constant speed, you'd have to apply a greater force than the frictional force. Okay? And the last kind of friction, one we didn't really get into, is called fluid friction. And if you've ever stuck your hand out a window of a moving car, you know the air is pushing on you and it pushes your hand backwards. Well, that is an example of air resistance, which is a fluid friction. And the cool thing about fluid friction is it actually depends on speed. The faster you move through a fluid, the greater the air resistance is, or the greater the fluid friction. Now, sometimes people confuse friction with inertia, and these are very, very different things. Okay, so inertia is not a force, but friction is. Okay, force is anything that causes an object to accelerate. It makes the object change velocity. Friction is a force, and it can cause acceleration. Okay, usually the acceleration that friction causes is always against the motion, so it's going to try to slow things down and stop them. Things stay in motion because of their inertia. You do not need to keep applying a force to keep an object in motion if there's no friction. However, because friction opposes motion, if friction is present, you have to apply a force to balance that. So when you have something that's like that cart that's rolling along the track, it's fairly low friction, so it's going to just continue rolling. However, there is a small frictional force, so over time it does slow down and stop. If you slide something across the surface of like the ground or a desk, there's quite a bit more friction, and so it slows down and stops even quicker. So that's due to friction, not inertia. Inertia wants to keep the object in motion, moving. Friction wants to take an object and always make it stop. So if something's at rest, inertia wants to keep it at rest, and so does friction. If something's in motion, inertia wants to keep it in motion, and friction still wants to slow it down and stop it. Okay? So friction and inertia are not the same thing. Inertia is the property that keeps the motion the same. It's not a force, it's just a property of matter. The more mass something has, the greater its inertia.